All right, part two. So we're going to talk a little bit about the out-of-network sources. Um, I feel a little strange about this period because I've already mentioned that out-of-network takes up 50% of tweets on average. So this to me is way too high. Now this isn't the problem with the out-of-network sources. The out-of-network sources might be perfectly implemented. This is going to be a problem with the ranking between them, which we'll talk about in part three. But let's talk about the sources and see if there's any questions here. So, there's going to be recommendations for you to follow people who are not, you don't already follow. So for new users, this is very helpful. For people who only follow a few people, this is very helpful. So yes, you want to have some recommendations of tweets or network sources, but the decisions of what should be bringing network sources to you is strange. So there seems to be there's two different kind of competing paradigms here. One is a social graph. So they have this GraphJet paper, which is almost all based on kind of efficiency paper. There's very little information about what the underlying kind of algorithm is. The only thing that seems to be kind of all like core algorithmic is, cosine similarity between two vertices. So if you are having a follow graph or a what they call it, engagement graph, then it's like, okay, you two have engaged with similar users, and it's therefore I might recommend you to this person if you don't follow each other. There's actually a little bit of debate later on, but we'll say it now. There's an interesting question between the dot product, which is this part, versus the similarity as a whole. And this question is whether you kind of want to normalize the relationship between two users based on how many interactions they've had. Basically, if somebody has a ton of interactions with other people who you've never heard about, do you want to basically say this user is less like you who than a user who has not had interactions with other people, but kind of the portion of people you did interact with is kind of similar between all three of you? I think cosine similarity is like good in this case. But that said, this GraphJet seems to be kind of smaller than the next thing, which is the sim clusters. So sim clusters is a little bit confusing. So there is the paper, which doesn't look like I have access. Then there is a custom matrix factorization algorithm, which is a Metropolis Hastings sampling, I assume. This isn't likely not the only thing that's being used in sim clusters, but we'll look it up. So I'm not going to go through all this. This is just basic gut feeling. Whenever you see a Monte Carlo algorithm, I have a kind of a negative reaction of like, okay, this uses randomness. How stable is this? If you run this twice, it's going to get the same results. Assuming that this is the case, good for them. But there could be some strange stability issues if your random generator is primed improperly or something. Okay. Anyways, what is this sim cluster thing? I'm gonna look at the
Hi,
video.
my name is Venus Atlur.
So okay, what it seems to be doing is kind of assigning users to communities. And you do it by first looking at kind of the influence of the top level people, and then figuring out which influencers are like together. It says like, okay, these influencers, 5 influencers together, these 4 influencers together, and then you have this person follows all 3, therefore they're in this community, and then they follow, somebody here, therefore they're also in this community, but they're very little in this community, and so on. These are definitely this community. So you have these basically, I think, weights of, you're 80% a football fan and 20% a machine learning fan, kind of thing. Okay. Then they get this like very sparse vector, basically, I guess, for every community. That's kind of interesting. It seems very big vector that they're doing. And then they would look at tweets that, are popular in this community, and they would figure out that like, okay, you haven't seen this tweet, you don't follow this person, but it's popular in your community, people are talking about it, so maybe we should recommend it. It's not, like, I don't see anything obviously wrong with this. Like, if you look at these communities, they seem like logically correct. Like, okay, you have the pop community, you have Hollywood, you have the news, you have sports. So, of course, it's hard to tell, like, okay, they get the head community right, but it's hard to tell if this algorithm gets kind of smaller communities correctly. Like, do they get communities with less than 150 people correctly? And do they have a ML type training set where they generate custom data with small communities, and do these communities get picked up, right? I would have to run the code. It's possible. The answer is yes. The more the users from a community like a tweet, the more the tweet would be associated with the community. I mean, this makes sense. The main question I would have here is, like, do users in multiple different communities get like a penalty? So basically, if you're saying you're 50% in pop and you are 50% in news, does your vote count as only 50% for a tweet? Or does it count 100% because you're at least in pop? So there's this question of like, can a user effectively affect many things on the site by following more people, or does following more people somehow ends up being a denominator somewhere? So there's a question of kind of incentives of like, are my tweets going to be seen more if I follow Selena Gomez? Like, that's the question. I don't know. Like, maybe I should try to do that right now, and we'll check back tomorrow. Okay, cool. So, okay, this is going to be a shorter part because I want to spend a lot of time on ranking in the next part.